Hello everyone, welcome to term 3. Hoping you've had a wonderful holiday and you're excited to continue on with our wonderful journey in specialist maths. What's really exciting about this semester is we're getting into brand new stuff here that is more in depth of things that you've already looked at. For example, with trigonometry, we're now starting to tread new waters, so I hope you're really excited about that, as I am. We are starting with chapter 14, which is about trigonometry, and this is going to be an extension to everything you've been looking at in the previous chapter. So let's go along. So today we're starting with 14a, reciprocal trigonometric functions and the Pythagorean identity. What you need to be able to do is find the exact value of a reciprocal function, derive identities, and then use identities to simplify expression. I'm going to preface this by saying I'm working off the assumption that you are well prepared in the methods circular functions course. So what you need to be able to do is understand the unit circle. You need to be able to find exact values and solve equations. So if you feel like you're not really confident with that, what I would suggest is that after this exercise, please do continue watching the video, but after this, go back to your methods work, get confident, get familiar with it, and then you can come back and continue working on this. So starting off with reciprocal trigonometric function. The word reciprocal in maths is really just the simple thing to do is to flip. So to reciprocate is doing the opposite. So, the reciprocal of 2 is 1 on 2. And so when we're looking at trigonometric functions, what we're actually doing is broadening our knowledge of them, because all we've known so far are these 3, sine, cos, and tan. There's actually many more trigonometric functions, and we're introducing you today to the reciprocal trigonometric functions. So what happens when I flip sine, when I find the reciprocal of sine? So that means 1 on sine. And we get this new trig identity, or function rather, called cosec. What happens when I flip 1 on cos? I get the new function sec. And what happens when I flip tan? I get cot. So just note that because tan is sine on cos, when I flip it, I get cos on sine, and that is what cot is equal to. So these are your 3 new trig functions that you need to know: cosec, sec, and cot. The ways to remember them: cot is really easy, I think, because there's a t, tan and cot. And the way that I remember this one is that cos and cosec, they both got that co, so they belong to the opposite trig function. So cos is not equal to cosec, it's the opposite. I don't know if that kind of works for you, but whenever I go to write the opposite or the reciprocal of cos, I automatically try to think of cosec because they both have a co, and then I remember, hold on, cosec and cos, they can't both have co, it has to be the opposite. So I don't know, do with that what you will, if that helps you remember, but I try to remember that the co's do not go together. All right, so really we just treat them exactly how we've been treating sine, cos, and tan, but it's just flipping it around. So with this example 1, find the exact values of each of the following. The first one says find sec 2 pi on 3. So instead of trying to figure out what that exact value is, I'm going to first rewrite this into a trig function that I am familiar with. So remember, sec is going to be equal to cos because only one of them has the co. So this is the same as saying 1 on cos 2 pi on 3. And now all we have to do is just focus on this. Remembering with your exact values, 2 pi on 3 is in the second quadrant and cos is negative in this quadrant. So I'm going to get a negative value. And then, of course, referring to our table, we're going to get that cos of pi on 3 is equal to a half. So that's going to be 1 on, and it's negative a half. And then, of course, a whole number divided by a fraction, what we do is we flip that fraction. So we get that sec is equal to negative 2. Next, for part B, something very similar, cosec. Now, cosec can be written as 1 on sine. So 1 on sine, 7 pi on 6. If we consider 7 pi on 6, that's in the third quadrant, and sine is negative in the third quadrant. So what is sine pi on 6? That is also 1/2, and it's going to be a negative because it's in the third quadrant. So flip that around, we get negative 2. Finally, for cot, that's 1 on tan, 5 pi on 3. 5 on 3 is going to be in the fourth quadrant. Then we consider what is tan of pi on 3, which is going to be root 3, and it's negative. So I end up with negative 1 on root 3. So that is how you work with your reciprocal trigonometric functions. You can notice that it's very similar to how we usually work with it, but it's just that it's 1 on. So we often end up with flipping the answer. All right, example 2 involves us solving. So again, if you're unsure about how to solve, please do go and work on that in your methods course before you attempt the reciprocal. But other than the fact that you have to do a little bit of a flip at the beginning, everything is the same. So find the values of x between 0 and 2 pi for which sec x equals to negative 2. So before I even start, I'm just going to put it in terms of cos to make it a lot easier. So we'll have 1 on cos x equals to negative 2. And now when we go ahead to solve, we always want our cos, sine or tan to be on the top. So what I'm going to do is I'm going to flip both sides. Now just consider that there's a 1 over there. What we're going to do is I'm going to flip. Now if I flip one side, I need to flip the other. The other way that you can kind of think of it is I multiply the cos x over to that side and then I divide by negative 2, which is probably the proper mathematical way to think about it, but we can also consider flipping both sides around. So that'll be cos x is equal to negative 1 on 2. Now we go on with our normal processes that we do when we solve equations. So the first thing that we need to do is consider what is our base angle. So our base angle means what angle would give us, what angle of cos would give us negative 1/2. Now don't worry about the negative for now, so just think of cos of what gives me a half. Referring to your exact values table, you should be thinking about pi on 3. So my base angle would be pi on 3. So the way to think about that is that cos pi on 3 equals to 1/2. Now the second thing I need to consider is which quadrants does this occur in? Because it's negative, we know that cos is negative in quadrant 2 and in quadrant 3. So what are the rules for quadrant 2 and 3? That's pi minus theta and pi plus theta. So if that's the case, if this is what x is equal to, pi minus theta, pi plus theta, and we also know that our base angle is pi on 3, we can go ahead and substitute that in. Pi plus pi on 3 and solve for it from there. So this is step 3, substituting it in. That'll be 2 pi on 3 and 4 pi on 3. So that there are all of the values for which sec x equal to negative 2. So if we were to graph the function of sec and to draw a line through negative 2, where would they intersect? It would be at 2 pi on 3 and 4 pi on 3. Really, this entire thing should be all very familiar. The only new thing is this part where we write sec in terms of cos, and then we need to do a little bit of a flip to get it onto the top, and from there you solve it as normal. Okay. Part B, very similar. Cot x equals to negative 1. So instead of cot, we're going to write it with something that we know that's familiar, which is tan x is equal to negative 1. We're going to flip both sides, which ends up still being negative 1. So if I think about negative 1 on 1, flip them both, well, 1 divided by negative 1 is still negative 1. So where does tan x equal to negative 1? Again, I can consider all of the steps that I did before. So tan of what gives me 1? Again, ignore the negative. Tan of what gives me 1? That will be pi on 4. That's my base angle. Then, which quadrant is this going to occur in? So we're working with negative. Tan is negative in quadrants 2, quadrant 4. What are the formulas for these? That's pi minus theta and 2 pi minus theta. And then all I need to do is substitute in my base angle to be able to find those specific angles. So I end up with 3 pi on 4 and 7 pi on 4. You can also do this using the CAS calculator. So first of all, check that it's in radian mode as we are using radians in this case. You can just go ahead to solve it as normal, type in your equation, but the one thing you have to remember is that you include your domain. If you don't have your domain, it's going to come up with a general solution. It's going to have something that looks like n, pi, plus, and all this extra stuff that you don't need to worry about at this stage. If you need sec and cos, you can access it using the trig button, which is on your left-hand side. So do practice this on your CAS calculator, but really it's no different to doing it in methods, except now we're using sec, cot, and cosec. Okay, the second part to this exercise, which is about this thing called the Pythagorean identity, and I'm sure you have come across it before, but we're going to go in a little bit more depth to it. So this is your unit circle here, which you've been working with for the last couple of weeks in methods. We do know that the equation of the circle is x squared plus y squared equals 1. You would have also discovered that your x value is equal to cos x, cos theta, and your y value is always sine theta. So if I have a specific point here, x and y, that is the same as saying that is cos theta and sine theta. So what we now want to do is figure out what the relationship is between cos and sine. Now I can simply sub in cos theta and sine theta into this equation of the circle, but another way to do it or to consider it is using Pythagoras' theorem. So with Pythagoras' theorem, what we know is that c squared is equal to a squared plus b squared. If this particular distance here is x or cos theta, then what we can say is that we have cos theta plus, and this is y squared, which would be sine theta, and that needs to equal to the radius, which is 1. So from there, we get this particular relationship. 1 equals cos squared theta plus sine squared theta. Now I just want you to note this little squared that we write in the middle is the same as writing this, but just in maths, for shorthand, we just write the squared inside so that we kind of don't get confused as to whether that squared belongs to the theta or not, and just to reduce the amount of brackets that we need to use. So it's just kind of a convention to be writing the squared in here rather than on the outside, but it means the same thing. So this identity is very important. Cos squared theta plus sine squared theta is equal to 1, and you can derive it using this unit circle. So these other trig identities, we've got 2 more, can actually be derived from this one over here. So what I might get you to do now is to try and pause this video and try to think about how is it that I might get these 2 identities from this one. I will continue on in a moment. Okay, so hopefully you've given it a go yourself. If you haven't, that's okay. I'm going to go ahead and show you how to do it. So if we have 3 identities, the first one we've just figured out now from our unit circle. For our second identity, the first thing I can see is that this cos squared theta has become a 1. So automatically, the first thing I'm thinking of is I'm just going to divide everything by cos to get that 1. So if I start off with cos squared theta plus sine squared theta equals 1, I'm going to go ahead and divide everything by cos squared theta. Now cos squared theta divided by cos squared theta is just 1, plus sine on cos is equal to 10, and we know that 1 on cos is sec. Now I feel like my computer has not printed this very correctly. Remember how I said we write it over here. So that's really how it should look. So that's the first formula there. Now for the next one, what I can see is that 1 has turned into a cot. I know that 1 on tan is cot. The other thing is I can see is that the tan has turned into 1. So that's further indication that I have actually just divided everything by 10. So let's go ahead and try that out. Actually, you can do it that way. I've just thought of an even simpler way to do it. Don't worry about number 2, just consider from number 1 again. Sine has turned into 1. Even easier, let's just divide everything through by sine. So if I start off with my original trig identity, divide everything through by sine, this is much easier. I'm going to get cos on sine. Remember, sine on cos is tan, so then the opposite of that, cos on sine, is going to actually be cot. Sine on sine is just 1, and then 1 on sine is going to be cosec. So here is how I get 2 more identities. So together, well not together because there's 3 of them, but all 3 of these form some identities. So what that means that the relationship between the 3 of them are always going to be true. So what we're going to do is we're going to use these identities now to help us solve a series of problems. So in example 3, they've given us if tan x is equal to 2 and x is between 0 and pi on 2, find sec x. So they've given me tan and I need to find sec. So what I'm going to do is I'm going to refer to my identities and I'm going to have a look at, well, do any of them have a relationship between tan and sec? And in fact, I can see that number 2 does. So 1 plus tan squared theta equals sec squared theta. So that's the first thing I'm going to do. Write that down. And now it's really just a matter of substituting in and solving for sec. So I know that tan x is equal to 2. And note, because x is my variable here, I'm going to write the rest as x. And now I just need to solve for sec x. So that's going to be 2 squared is 4 plus 1 is 5. And then I'm just going to get sec by itself by taking the square root of both sides. Note that when you take the square root, it's both plus minus, and because I'm in quadrant, well, this is quadrant 1, which is between 0 and pi on 2, I'm going to end up with a positive because tan is positive in this quadrant. So that'll be root 5 is equal to sec x. Part B, if tan x equals 2 and x is between 0 and pi on 2, find cot x. So this time what we need to do is consider the relationship between tan and cot. There is no identity in this particular list, but hopefully you can see that the relationship between tan and cot is just that of a reciprocal. So if tan x equals 2, then 1 on tan x, just flip both sides, will equal a half, and we know that 1 on tan x is cot x. Just to make my x's clearer. So remember, you can just flip both sides there. Okay, so that is example 3. Example 4, if sine x equals 2 on 3 and x is between pi on 2 and pi, find the values of cos x and tan x. So what I can see here is they've given me sine x and we need to find cos and tan. So just like before, we're trying to figure out what we have a relationship between. The first thing I can see is I've got sine and I've also got cos. So I'm already starting to think of our original identity, which is between sine and cos. And then to get tan, well, tan's pretty easy if you've got sine and cos because tan will just equal to sine on cos. The other thing to consider is that x is between pi on 2 and pi, which means it is in quadrant 2. And we need to consider that both cos and tan are negative in these quadrants here. Okay, so the main identity I'm going to use is sine x and cos x is equal to 1. And basically I'm just going to substitute and then solve for cos, just like we did before. So sine is 2 on 3 squared plus cos x is equal to 1. I'm going to do, well, expand that, so that's 4 on 9. I'll take it to the other side. So 1 minus 4 on 9 is 5 on 9. And then I'm just going to take the square root of both sides. So that'll be root 5 on 3. Now, because it is, though, in quadrant 2, I know it's going to be negative. So remember, when you take the square root of a number, it's both plus minus. So that's why I'm going to have the negative version of that number. And now finally for tan x, it's just a matter of substituting in. So that's sine x on cos x. Sine is 2/3. Cos is negative root 5 on 3. What we can do is cancel out those 3, so I end up with negative 2 on root 5. Like, you can also rationalize the denominator. So you end up with negative 2 root 5 on 5. All right, we're up to the last question of this. One thing that you're going to do quite often in this chapter, and one reason that I absolutely love this chapter, are proofs. Now, we have done a lot of proofs throughout the year. Personally, I hate proofs, I always tell you that, but when it comes to circular functions, it's really fun. And it's kind of like a puzzle. I'm sure you're going to enjoy it. It might be a little bit confusing, but just hold on and I'm sure you're going to end up loving it as well. All right, so example 5. Prove that 1 on 1 minus cos theta plus 1 on 1 plus cos theta is equal to 2 cosec squared theta. Looks kind of confusing, but let's work at it one step at a time. Now with a proof, what we generally want to do is start from one side and then simplify it down, and you'll end up with the expression that's on the other side. So let's just focus on these fractions. Now the other thing is, when there's fractions, the first thing I try to always do is get them onto one denominator. So that's exactly what I'm going to do. To get them onto one denominator, what we want to do is multiply by the opposing denominator. So I want 1 on 1 minus cos theta. I'm just going to write this out again, but with a little bit more space, just so you can kind of see. I'm going to multiply it by the opposite denominator so that we end up with the same denominator on both sides. And whatever I do to the bottom, of course, I have to do to the top. Okay, now one thing you will hopefully notice, 1 minus cos theta, 1 plus cos theta, this is a situation of dots, and it's the same on this side as well. So what that means is that the denominator is going to end up being a squared minus b squared. So 1 squared is just 1 minus and then b squared. At the top, I'm just going to multiply this out by the 1. So that'll be 1 times 1 plus 1 times cos. So it'll just be 1 plus cos theta plus, and then on the other side, it's 1 minus cos theta. So at the top, I end up with 1 plus 1, which is 2. Cos theta minus cos theta is 0 on 1 minus cos squared theta. We're almost there. We can see that it is looking quite simplified, but it's not quite what they have given me. So let's consider what is 1 minus cos theta, and we're going to refer to one of our trig identities. So our trig identity that I'm thinking of is sine squared plus cos squared is equal to 1. Now I can see that I have a 1 minus cos squared here. Why is that the case? Because if I take the cos squared to the other side, I end up with 1 minus cos squared theta. 1 minus cos squared is equal to sine squared theta. And that's just something you'll get used to. So this is just another variation of this particular identity, and you'll get used to recognizing that that is equal to sine squared theta. So what do I end up with? That's 2 on sine squared theta. And then what we also know is that 1 on sine is equal to cosec. So if I have on sine squared, that's the same as saying cosec squared. That's how I take it to the top. So I'll end up with 2 cosec squared theta. Hope that was really fun for you. Maybe not for the first time, but you'll get used to it and enjoy it as we go along. That's the end of exercise 14A. So please continue, please work on those exercises. Thank you.